Derivatives with E, product rule, Leibniz's notation. So, I have here what we'll generally be focusing on with derivatives with e to the power of x. So, when you have a function, say y, and it equals e to the power of x, when you go to derive that function, you just get e to the power of x. It's just how it works. It's just how it's done. And it's how we will do it. When y is equal to e to the power of a number times x, in this example it's k, so it's e to the power of kx. When you derive that, you get ke to the power of kx. I have a derivatives on chain rule that explains how you get that, but that's how they do it, that's how it's done, and that's how we will do it. And over here is just the product rule. If you've seen my other videos, you would know what this is. It's just y, a function, and within this function you have two functions. We call them u and v. When you derive y, you get v times the derivative of u plus u times the derivative of v. So, let's do some examples. Say y equals ex times 2x. So, y, and when using the product rule, you have a function multiplied by another function. Just like u times v, we have ex times 2x. So, we label u as ex, and we label v as 2x. The derivative of this function, dy dx equals v multiplied by derivative of u with respect to x plus u multiplied by the derivative of v with respect to x. So we have to find the derivative of u and the derivative of v. Like I said before, the derivative of ex is just ex. The derivative of v is 2x, so the derivative of v would just be 2. So now we have these values, we can input them into the equation. So dy over dx, sub in v, 2x, multiply that by derivative of u with respect to x, ex, plus u, which is ex, multiplied by the derivative of v with respect to x, which is 2. So we can rearrange this so it looks like ex 2x plus ex 2. And if you wanted to rearrange and simplify a bit more, you can write ex 2x plus 2. Now this is because you have ex multiplied by 2x, and you also have ex multiplied by 2. And they're both added together. So this is when you if you expand these brackets and you multiply ex by 2x and ex by 2, you will get this. This is just a neater way of putting it. If you get confused with that, you might have to watch it again or practice examples like that one. We will do another one now, so you can hopefully understand it if you don't. So let's start with y equals ex multiplied by x squared plus 3. So just like before, we have a function which is ex multiplied by another function which is x squared plus 3 Separate the page. U we can make equal to EX, and V will make equal to X squared plus 3. Just like before, the derivative of this function is V multiplied by derivative of U plus U multiplied by the derivative of V. So we need to find the derivative of U and the derivative of V. The derivative of U, EX, just becomes EX, and the derivative of X squared plus 3 just becomes 2X. And so, if we sub these numbers in, we end up with V, which is X squared plus 3, multiplied by EX, which is the derivative of U, plus U, EX, multiplied by derivative of V, which is 2X. Now just like before, we have EX multiplied by this, plus EX multiplied by this. So, if we bring the EX out and multiply it by the whole thing, as such, we can do this because we have EX multiplied by X squared plus 3 plus EX multiplied by 2X. Now you can make this look neater and put it as EX because in this case, because it's not to the power of anything, the numbers are just freely added together. Because if you were to expand these brackets, you would have EX multiplied by X squared, EX multiplied by 3, and over here you'd have EX multiplied by 2X. If you expanded these brackets, you would get these. So, let's do another example. So, let's say y equals e to the power of 5x multiplied by sine x. So, just like before, we have a function e to the power of 5x multiplied by another function sine x. If we separate the page and write in our values, u can be e to the power of 5x and v can be sine x. The derivative of y with respect to x is again v multiplied by the derivative of u plus u multiplied by the derivative of v. So we need to again find the derivative of u and the derivative of v. The derivative of u being e to the power of 5x, we know that the rule states that if we have e to the power of a number multiplied by x, then the derivative of that is that number multiplied by e to the power of that number by x. So we bring the 5 down, we keep it the same. Unlike derivatives, when you used to bring the power down and take it away from the original power, when you have e and you bring the number down, or you bring the derivative of that down, you keep everything up here the same. You see how there's the similarities with these? Okay, and back onto this, the derivative of v being sine x, is cosine of x. So if we input these values, what we get is v sine x multiplied by the derivative of u, 5 multiplied by e to the power of 5x, plus u, which is e to the power of 5x, multiplied by derivative of v with respect to x, which is cosine of x. The funny thing about this is that the 5 is actually multiplied to that e. So if we could still bring the e to the power of 5x out the front, as so. We could have e to the power of 5x sine x multiplied by 5 plus cosine of x. Just like before, if we were to multiply, if we were to expand these brackets, we would get here, we would end up with this up here. If we were to expand these brackets, we would get this. To rearrange it and make it a final product, we would have e to the power of 5x and bring the 5 out the front, and that there is the first derivative of that function up there. Thanks for watching. Hope you enjoyed.